So, hi everybody. My name is Elad. I'm the founder and CEO for Teridion. Always like to start my presentations with a little song and dance. So, music, please. Just kidding. As Dave mentioned, people call us the Waze plus of the internet. One thing that I do have, two things I have to say about what Dave presented is, first of all, it's important to understand that whatever we'll show you, there is no software installed on anything. So even the machine on Amazon, there was no software installed over there. You can actually test it later on if you want to from your PC, and I haven't installed anything on your PC. Magic. And there's nothing installed on the end server. So it's really a service. So that's the first thing I want to say about Dave's presentation. The second one is that Dave was really helpful, and we prepared this presentation, and this morning he said, hey, I updated the presentation. It's not what you have. So this is going to be also my first time to see those slides. So you'll see how good of I can improvise as I talk. So with that in mind, we'll discuss a little bit about what is Teridion, and I'll answer all your questions. We're going to talk about the content today and what are the challenges that you have today. How is the performance impacting the business these days? And we'll describe the cloud-based solution, which is the core of what Teridion does. So in today's world, we have all those cloud infrastructure as a service providers. So you have Amazon, Google, AliCloud, Software. You can name a few, DigitalOcean, Vultr, a lot of cloud providers. And they give you the infrastructure to build applications on top of that. On top of that, we have this new breed of a cloud-based application, which are Box, Twilio. It allows you to do a lot of things, and instead of having the infrastructure in your on-prem, you're actually having it in the cloud. And we're able to do a lot of really cool things and save money, etc. I'm not trying to convince you to move to the cloud. I'm pretty sure you're already there. However, those new era of cloud applications have a new challenge with it. So I'm sure you all know about a company called Slack, for example. So Slack, yep. If somebody can figure out what it is, great. So Slack is a cloud-based application, and it allows us to do interaction. Now, if you think about this, we expect all those cloud applications, where it's a backup or synchronization, voice over IP, all those cloud services, social networks, we expect them all to work as good as it does for the enterprise, but it's out there, it's remote. But we still want it to feel as if it's on-prem. If you look at applications like Slack, like Twitter, like LinkedIn, like Salesforce, pretty much anything we use these days, they're not on-prem, but we like it to feel like it. There's a challenge here because the network doesn't work well. As a matter of fact, I can challenge you to do a speed test from your PCs. Don't do it now, because you need to pay attention to me. But later on, I'll show you how to do this. Do a speed test from here to India, for example. And we have a 100 megabit internet connection. Nobody will use it except from one of you. You'll test it to India, and then you'll see what's your effective bandwidth. Okay, and then I'll show you how to do the same thing with Teridion, because I promised you there's nothing to install. And so if you think about all those applications, it requires you to do, it's bidirectional. I send stuff on Slack, I upload a picture, I download something, I add something to my story on Snapchat. Yes, I learned a little bit about Snapchat. Thank you, Ben, for introducing me to Snapchat. Ben and my 13-year-old daughter. And we expect it to just work and to be fast. But we can't. And those types of applications can't even use the traditional CDN, which was, by the way, it's a great idea. I love CDNs. I understand you're meeting after this one, one of the other companies that one of the founders is formerly from original Akamai team. And so CDN is really, really good. If you have static content or videos you want to distribute to everyone, CDN is awesome. Use it. It's very, very cheap to a point where it doesn't even cost, it might not even cost you anything. But it doesn't solve the problem. You cannot use CDN to upload. You cannot use the CDN for what's called the long tail. You can just use the CDN for your box, Dropbox, whatever service you're using these days. And there's no, there's some security issues that tie with that, but we're not going to even talk about that. When you think about this, even one of the most famous companies in the world, did not build the CDN eventually. Huli did not build a CDN. There's no Huli CDN. So we expect it to be everywhere, and we want it to be right now. But our use of the network has changed over the course of the last over 10 years. But the network hasn't changed. It cannot change, by the way. The problem that I'm going to show you still exists for years, and it will continue to exist. Teridion has a new take on that. So, of course, the latency has issues, and it affects all of us. So if you're trying to upload a file, if you're trying to synchronize your photos or upload a video to your blog, it can take you several minutes, and that's in a good case. You might also want APIs that run much faster, regardless of the location in the world. And of course, all the personal web content. So take, for example, your favorite social network, let's say Twitter. You can cache on a CDN. It's actually a good use case to cache all the images of the profile pictures. But you cannot cache the feed itself. It's a web page. It keeps on calling JavaScript. There's back and forth communication all the time between your browser and Twitter. And all these things cannot be cached. They cannot use a CDN, no matter how you twist and turn it. Teridion solves all these problems, and we'll show more. And of course, conferencing, voice over IP I'm sure you've all seen been in the situation where you have a conference call and it just disconnects and doesn't really work, and then you can't hear the other side, and then the other side freezes. All those things can happen while you do a conference call. So with Teridion, all these things are gone. So let's talk about the challenges of the internet and why is this happening. So if you try to understand what happens when a packet leaves your PC, when you're trying to upload or download, same thing, it actually goes through all these routers along the way. And I challenge you to guess how many routers there are from LA to San Francisco. It's a short distance, right? You would think, look, LA to San Francisco is not a big deal. How many routers do you think you're going to find along the way?
Depends where you go.
10?
9.
9, okay. Any other guess? Well, you were very, very close, actually. Thank you very much.
14.
Any number you said, because you were the only one who said anything. But there's actually, on average, about 30 of them.
30?
30 of them. We've been testing it for a while, trust us. You're more than willing. I don't see us building trust here. But
The trace route's coming.
Yeah. The thing is, that the numbers of routers keep on increasing. And the reason is because routers have a limited capacity of how many entries they can have on their what's called the BGP table. We increase the number of devices because all of us have a PC, a watch, a phone, and maybe another Fitbit or whatever. So the number of routers keep on increasing. It's very good business for Cisco and Junipers. And those routers still work on what's called the BGP. BGP is the regular old routing technology, which means that if I need to route something to my friend over there, we're still trying to see if if there are 30 hops between here and LA. And so let's say on the other side of the table, Kevin is our VP Worldwide Sales, sits there, and I need to route traffic to him. And I'm going to do this through, I'm sorry, what's your name?
Brandon.
Braden?
Brandon.
Brandon, through Brandon. And I'll keep on sending the traffic through Brandon because that's what my BGP table says. You have to go through him because he's the cheapest way to go. By the way, that's how it works. What's called least cost routing. It's the cheapest way to go. But Brandon now is busy trying to see how many hops there are between here and LA. I'll keep on sending the traffic through him, but it's not really the most effective thing. There are other people who are actually listening to me and that can do a better job. But I can't go there because BGP is a very rigid, basically a table that says, at this time of day, send it over here because that's the cheapest route. Has nothing to do with performance or anything like that. So it uses cost-based performance versus routing. It has a single path. It can only take a single path, and it will stick to that path regardless. There's no way it will change it. And not only that, but there's no visibility. I do not know that Brandon is busy. And if there are 4 routers after that, if there's a router that's busy over here, this router doesn't know that this router will eventually connect to that router that will be busy. All this visibility is non-existing on the public internet. That's the way it is. It cannot be changed. That's the protocol. You cannot replace all the routers all over the world at once. So with these problems, what happens is that our effective internet is not as good as we would expect it. Another example is I have a 100 megabit internet connection at home. I'm able to stream one HD stream from Netflix. If my daughter starts to stream something, one of us will not see it in HD. And if you think about and calculate it, that shouldn't have happened because the HD stream requires about 5 megabits per second. For 2 of them, you need 10 megabits per second. I have 100. So I should be able to see at least 4, 5, 6 of them. Yet I'm not even able to watch 2 of them. And I'm sure this has not come as a surprise. So with that, we have the challenges of the routing of the internet. So we said there's no control over the internet, there is no visibility, and it's unpredictable. If I start to send traffic in one route, if something changes, if one of the routers is busy now, is doing something, is trying to see how many hops there are to the internet, from here to LA, I keep on sending the traffic over there. So this is why, if you do all the speed tests, you see that it looks like a jigsaw, because it's very unpredictable. So we have performance issue, we have predictability issue, and the bottom line is low performance, or not as good performance. So since you didn't want to believe me, and we're still getting the trust going on over here, here's a snapshot of a route between here and LA, if you don't trust me. So here's one of them. Of course, it can change on time of day, but since we're monitoring the system all the time, that can pretty much show that it's an average of 30. There are other services, by the way, that can show you the packet loss and issues between the leading providers. Then these are all the leading providers, and this is for a single day for those 4 hours. So issues are always happening on the network, but nobody really knows what to do about it. Or to detect those issues. I'm not really sure that I need to tell you about the impact of performance. Of course, you want people that read your blogs to see it immediately. There's an impact of how fast the page loads. You've spent, I'm sure, a great deal of time optimizing the page, doing CSS optimization, all sorts of things to make it faster. The funny thing is, you might have saved, 100 milliseconds. If you move to Teridion, you most likely save seconds on the same thing. So another thing that happens is that what we call here the Netflix time of day. 6 to 9 p.m., follow the sun, is where issues happen on the network because everybody's Netflixing and HBO Go and everything. So at any given time, there are issues all over the network, all over the world. And of course, the slower the performance, the worse the performance is, there's more latency, and there's loss, and the page load increases, and as much as the page load increases, customer satisfaction decreases, and revenue are lost. So you might say, yeah, but I have a CDN. This is so awesome. I can do everything. It's a really cool thing. Well, if you have a static page and static items on the page, that's pretty much good enough. I mean, you most probably don't need anything because nothing changes much. It's cached. It's very, very cheap, and it's one-directional. So if people are only consuming data from you, so if you have a blog, CDN is a great thing. You shouldn't replace it. It's bidirectional because people are just reading the blog, and obviously you're using HTTP or HTTPS. There's not much about it. However, when you want to go to other things to be bidirectional, if you're developing something that uses WebRTC or anything that has bidirectional communication, that's where CDN fails. All the solutions that CDN have for dynamic content are really event-driven. It caches it, and then it allows you to trigger something that will flush the cache and regenerate the cache. So nothing is really dynamic. There is no such thing as dynamic page CDN. It's a CDN with a short time to live and programmatically to renew it. And it also uses traditional WAN acceleration sometimes between the edge and the origin. But since everything is encrypted and SSL and all that stuff, it's not as effective. But that's what it is. So CDN doesn't solve all the problem. Actually solve a very small part of the problem. Huge amount of content, but small part of the problem. So you might say, yeah, there are other tools. There are ways to see what's going on the network. I have what's called real user management tools. And I would say, great, whoop-de-doo. So you have real user management tools. That's like driving on 101 and getting an alert on your phone, hey, you're stuck in traffic. Thank you very much. I know I'm stuck in traffic. What am I going to do with it? I haven't said you're going to do anything about this. You said, I know you're stuck in traffic. You're so smart. And this is why I always say that we're Waze++. Because Waze, as good of an application as it is, can tell you, here's where the traffic is, here's where I suggest you go. It doesn't force you to do this. I mean, you can choose to go wherever you want to go. And also, it can only show you the amount of available routes that it has. Teridion takes it to the next level. Teridion is like Waze and Tesla put together, where you have a self-driving car. So it will also force you to go to a route. You don't have any choice to do this. And when you think about this, if everybody in the world will be driving along, like Elon Musk, a dream, everybody will be driving a self-driving car with a navigation system like Waze, there will be no traffic jams because the knowledge behind it will know how to route traffic so it will not create its own congestion. When you get up in the morning and you put your office address in Waze, and let's say you live down in the peninsula, like in Palo Alto, and you want to drive here to San Francisco. Everybody wakes up, everybody puts their address at 7 a.m. It tells everybody, hey, 101 is clear, go ahead, it's green. And then everybody goes into their cars, start to drive, and guess what? We've just created congestion. Good for us. So with that in mind, if you have self-driving cars, it will know where other cars are driving and will not create its own congestion. So that's another thing. But when you have all those tools, so it can tell you there is something going on. But unless you prepared some really weird systems that duplicate data between one data center and another data center, and it doesn't really help you. So basically, the only thing that can help you is when your customers call you and say, hey, there is an issue, you say, yeah, but everybody else also has an issue. Well, let me correct that. Not everybody else. Everybody else who does not have Teridion has this issue. Because all the Teridion customers don't really care about this. Why do I care that there is issues in Atlanta, Georgia, some congestion over there? Teridion already rerouted my traffic around it. So let's talk about what is it that we do. If you think about this, the content provider, the boxes, the Dropboxes, all those companies, Slack, LinkedIn, what they want to do is to create their own backbone from their data center to all the users in the world. If they could do this, that's going to be awesome, because they will be alone. They could control it. They will know how to manage it. They can set the rules to it. That's what they want to have. So that's what Teridion gives them. We give them what we call the VBN, a virtual backbone network, that basically creates a virtual route between them and any user, anywhere in the world, whether he's on a notebook, on a cellular network, all the way to in the airplane. We don't really care where he is. We create a virtual backbone network for the customer. That's what he gets from us. But unfortunately, we also have reality. So this is the reality. In reality, we have all those core routers and all the problems that they have, and congestion and latency and all those things. This is where we want to be. This is where the reality is. And Teridion needs to bridge this gap. So this is what we do. Teridion creates cloud routing, an overlay network that basically understands in real time the underlying technology. We map the internet in real time using our proprietary technology called TMAs. I don't know if I have that in one of my slides in a few minutes, because again, it's a surprise for me. But so we have those TMAs that measure the internet on the IP level. And it's important to understand that there's a difference between doing things on the IP level versus just ping and HTTP requests. Because when you do things on the IP level, you can understand what is the topology of the real topology of the internet. Because you can say, oh, this route actually works really well for latency, has really good latency control. And this route has very good throughput. All those things, you can only detect them on the IP. If you just do ping, well, you know that there's somebody answering on the other side of the door. It doesn't really show you anything. So we had to develop our own technology, how to map the internet, how to measure it, and how to map the internet. And let's see if I have
So when you say you're mapping, are you saying like you take essentially the hops through a path at a certain point in time, and you record that in some way? So this is a good path for latency versus another one.
It's a good question, and it's a great question because I have a slide about this. Apparently, I have a slide about it. It's a surprise. So what we do is we have all those TMAs. Where is it? So we have what we call TMAs, Teridion Management Agents. We deploy those on cloud providers, and they run for whatever amount of time they need to run, about an hour, and they start to map the internet around them on the IP level. And so you have one of them that's located somewhere in the world, another one, and eventually those circles hit each other, and now we've mapped all the information between this one and that one. So we gather all this information, now we delete those and we deploy them in another place, and we actually leverage the cloud in a very, very high scale. And we use about 20 different cloud providers at any given moment. We developed our own technology that looks at all the cloud providers as if it was one cloud provider, just deploys all over the place. And those TMAs measure the internet and understands the topology. And all this information is being sent up to what we call the TMS, Teridion Management System, that now understands it can map the internet in real time. Did this answer your question?
I'm just curious how you do that. What do you mean you map it? How does that actually manifest itself?
So this is a little bit of our proprietary technology, but just to understand, what we do is something similar to a radar.
Okay.
We start by figuring out who is around me and sending our specific packets to all of those. This allows us to get some measurement. And once we do this, we go another layer around it, and then another layer, until we hit another one coming from another direction. Then we map everything between them.
Okay, so geographically?
I'm sorry?
You're saying you want to know who's around you in terms of what?
It could be geographically, but sometimes it's the actual answer for this. The real answer is no. It's not geographically, because interestingly, sometimes Frankfurt and Amsterdam, if you have two TMAs over there, they will hit each other later than Amsterdam and, for example, Israel, because you would think that geographic locations is the key thing. We were always taught that. CDNs were always taught. Realistically, if you look at the measurement of the internet, that's not actually the.
Are you reacting to any kind of topology changes in the BGP network? Because like you're saying you do it once an hour, but my customers directly connected see changes every minute. Awesome.
That's a great question. Now, BGP get congested all the time. So the topology of the BGP doesn't change. Let's agree that it hardly changes. Routers stay there. And that's one of the problems, by the way, because I'll keep on sending traffic through Brandon regardless. But the changes in topology might be Brandon might be busy now, and at certain time of day, traffic is being sent. This is the least cost routing, now that's the least cost routing. So that's the changes that do happen on the BGP, and that happened in real time. And that's a great question, because in a minute, we are able to measure those in real time. Because there's an action of mapping the internet, understanding it, and now there is an action of measuring it. Because we have thousands of routers, and the next slide, I hope, thousands of routers, we can measure this in real time, and I'll show you how we change it also in real time.
So fundamentally, are you bookending it? You're building an overlay, you're bookending, and you're optimizing traffic through the tunnel.
So we're not optimizing the traffic, we're not touching the traffic, but we're creating an overlay, and we're doing a different routing than.
Yeah, you're overlaying you're routing on the top, and you're just you're bookending it though, most likely. You're tunneling the traffic somehow to bookend it so that you can route it however you want to route it through whatever hops you have.
Yeah.
With some encapsulations, your own proprietary tunnels, creating your own, forcing the traffic.
Yep. So we're doing something like that, forces the traffic to go where we want to go and change it, and we're able also to change it in real time. So, for example, if somewhere is congested, we change it. So our customers not only see a huge increase in performance, like you saw, but also see a very persistent performance. So, for example, one of the ad networks used to have their ad load in about 1 second, 1.1 second. With Teridion, they're now at about 300 milliseconds. But not only that, but they're always, they're at around 290 to 305 milliseconds, but always in that range. Before that, they were 1.1. On average, they were 1.1. Sometimes they were 900 milliseconds. Sometimes they were 3 seconds. It changes all the time. So once you start using Teridion, you'll also see for example, on speed test, it's not a jigsaw. It's basically like a dead man's heartbeat. It's flat. It always stays the same.
So I just want to make sure I got this clear in my head. This is what it sounds like to me. So you can't change the underlying ISP routing of the internet, but you can place your own routers all over the place. You can monitor paths between all those routers to figure out which one's better, and then using tunnels between your routers, you can control path between them.
That's very close to what we do. With an additional thing is, we're not measuring between the routers. We're understanding how the internet actually works, and then when we see traffic coming in, we say, all right now the best way to go is, so this is the virtual routers. Right now the best way to go is like this, and then we can change it because we use the cloud. So we can say, right now we have to go from here to here to here to avoid the congestion over there. But at some point we might say, hey, actually over here is an empty space. There's no router over here, but our TMA, TMS, our management system says, you know what? I figured that if we have a router over here, it will be even better. So we deploy one in real time, shift the traffic over here, and we can delete this one.
Okay.
And so this gives us an agility and a way to do things that are really, really agile, really adaptive to anything. If there's a peak in performance, if there's a burst of traffic, we can scale up. We have unlimited scalability, and we can, guarantee the performance. Yes.
I'm trying to position it against the SD-WAN, but it seems to be going beyond the SD-WAN as you are controlling the paths in the internet. So I was wondering, you can position your product for the VPNs also, for those VPNs which are going on the internet.
Yep. It works for anything. It pretty much works for anything. So I have a VPN. I use SSL VPN. I use SSL VPN over Teridion. As a matter of fact, what we like to call it is the SD Internet. It's a software-defined internet, not the software-defined one. Now, you have another thing that is very different between us and SD anything, is that SD-WAN or so SDN is the more closest thing. SDN is when you have you manage a known finite amount of devices that you control. You deploy them on your VMware or your hypervisor, and you do not delete them. It does not go away for you. We manage thousands of devices that are out of our control. Unfortunately, cloud providers have issues, and sometimes the servers fail, and when you have thousands of them, it happens every couple of minutes. So we had to develop our own management technology that can manage thousands of devices and changes all the time, adds, deletes all the time. It's not a finite amount. It always grows. And that can basically overcome things that just happen out of your control. In SDN, you control everything. On our technology, things happen out of our control, and we need our system to be able to have high availability regardless.
Well, the more mature SDN technologies do probing, various types of probing, and they deal with bandwidth changes and latency changes and make intelligent decisions.
Absolutely.
So I'm trying to understand the differentiator between the more mature SDN or SD-WAN technologies and this.
So let's talk about SDN, SD-WAN, and then Teridion. Okay, and compare SDN and Teridion, SD-WAN and Teridion. So SDN is for a data center. It's not for the internet. So it has to be over your controlled environment. You have 152 devices and you manage them. If you want to add another one, you go ahead in your management portal, you add another one, you select, I want you to deploy it on this on-prem device. It's there, you plug it into the system, it doesn't change. We have, at any given moment, since I started my part here, until now, most probably we had over 100 changes in the system. Over 100 servers were added and or deleted. And we cannot, some of it was out of our control. So we had to develop a system that is not a simple SDN. That's one. The second thing is we have to, an SDN, you have your kernel, you know your hypervisor, everything is really well known because you own it. We don't have anything. We're standing on the shoulders of giants. We have accounts on pretty much any cloud provider. So it's a very different thing about managing unlimited, agile, non-controlled set of devices versus an SDN, which is very controlled and also in a very controlled environment, a reliable environment. So that's with SDN. SD-WAN, on the other hand, is mostly used for, is the new generation of the network, the WAN optimizations. So basically it says, instead of putting the riverbed devices, let's use SD-WAN. So now you can have, multiple places, and you either, you MPLS to a POP, or you do a VPN to a POP, or GRE to a POP, and those POPs are all interconnected. But again, the whole environment for all those SD-WAN companies is a controlled environment. They have X amount of POPs. That's what they control. That's what they have. If you're in the airport and you're trying to connect to the SD-WAN, well, good luck with that. If you're trying to connect to any service that is not directly doesn't have a peering with the SD-WAN, good luck with that. Nobody has a peering with Salesforce, for example. They don't allow you to do it. So none of the SD-WANs have peering with Salesforce. They do have peering with Office 365, for example. They all have it because you can get it practically for free from Microsoft, but none of them have it with Salesforce. Or if you want another cloud or Box or Dropbox or Google Drive or what may, it's a great alternative to the WAN optimization of the past. It's a WAN optimization as a service, controlled environment, finite environment, not our use case. Our use case is for all those cloud services, content providers, and all the users all over the world. We don't care if it's in their office, in the airplane, in the airport, if they do VPN, or if they do HTTP or voice over IP, or what may. Did that answer your question?
Kind of. Go ahead and we'll see how it as it moves forward.
So the VBN, what we call the VBN, the Virtual Backbone Network, is something that can go from different places in the world. And it can do really cool things that BGP cannot do. For example, we had a customer that wanted to try from Japan, I think it was, or the Japan or Singapore, I keep on forgetting, to a data center in San Jose. Now there is a fiber, a lot of fiber going from Singapore to, or Japan or whatever, to San Jose. However, Teridion, because it measured all those things, actually created a route for him to go to Australia, from Australia to Seattle, to Chicago, and then to San Jose. The results were almost 60 times better. The reason is that this whole pipe between Singapore and San Jose was really congested. And we just took him on a different route that was clear. Now, BGP cannot do this. First of all, it's a directional protocol. There are other issues about that. But also, it cannot see that there is a congestion. It cannot create a new route around it. So it can span different regions. And as I said, it scales up and down, which is another difference than SDN and SD-WAN. You know, we change the numbers of nodes and, so to speak, changes all the time. Since we work on the IP layer, we don't really care about what type of traffic you're pushing. So there's no need to give us any SSL certificates or anything like that. There's no issue with security. I mean, that's one of the reasons why, for example, Box and Ignite chose us. It was not only that we were better in performance than pretty much all the other competitors. It was also that there was no security issue with this. All the other solutions, even the ones that, well, all the other solutions don't support bidirectional. So it's not upload and download, not really upload and download. They claim they have something for the upload, but it doesn't really work. And also it requires you to give the SSL certificate to them. Because the traffic has to go through them, and basically they cache it a little bit over there, and then they send it to your headquarters. Teridion doesn't require anything like this because it's a pure routing technology, and so the SSL certificate is not needed. And then that also allows you to do pretty much anything for any application. If you have a gaming application, a real-time gaming that requires UDP or TCP, we don't care what's the application. Just tell us how, tell the application to go to our router, and we'll take it to the other side. So it's like having an off-ramp at the content provider and on-ramps all over the world with HOV lanes going to that off-ramp by the data center.
Question, I've just been thinking about the monitoring side of things. You said that periodically the nodes that perform these path computations or basically qualifying these paths with some sort of performance score. You said you move those around, or are they always on? Like basically how often, how up to date is that? If something happens on the internet that starts to affect performance, how I guess quickly can you react to that?
So we can react within milliseconds to seconds.
So you're always running these tests, basically.
So the tests are mostly for places where we don't have current information. Then we deploy them. But by now, since we've been with the system for almost 2 years, and we have, I think, close to 5,000 routers all over the world that also communicate, we pretty much know what's going on.
So that's sort of like your pioneer, right? If you don't have infrastructure there, because your infrastructure can probably run similar tests, right? It knows the performance metrics between two routers, obviously. So this is just you putting it there. If you don't have that infrastructure there, you can get those metrics before you do.
That is true. That's one thing. The other thing is, let's say I'm right now, I know the performance between me and you. Mm-hmm. But who said that, that if I'll go here, it will not be better? So these situations sometimes need to be recalculated. But since we've been running for a very long time, we have statistics. By now, we even have trends, and we we can pretty much understand what's going on in the underlying and know that this router changes their BGP table at midnight or whatever.
Right.
We already know so much things about it. Now, it doesn't mean that we rely on them, but this is where we have all those TMAs testing all the time. So it's a combination of real-time traffic that's running on the system, TMAs to add information, and some proprietary knowledge that we can understand about the network.
So when I fire up my web browser and want to basically transit through a VPN, how do I get onto the VPN? So
the only hardware that you need to use it is a credit card. But no, you're actually. So our clients are the content providers. So if you're a client of Box, for example, and you're a paid customer for Box, I don't think they give it to their unpaid customers, but it's not of our control, then they have a way to point you to a Teridion router. And once your traffic hits the Teridion router, we know how to get it to the other end. So there's nothing you need to do nothing you need to do, or nothing you can do on your browser. If you have a website or a content that you want to use Teridion for, that's where you sign up with us, and then we help you. It's configured, and usually it takes some minutes to get everything up to Teridion.
Do you have some service provider as a customer?
Service provider like Comcast,
for example, like Sync.
So no, we're actually not targeting these at the moment.
Can be a use case for them.
It can be used as a use case. It can be used as a use case. Why don't you visit us next year and we'll talk about this a little bit more. Okay? Said enough.
Let's assume that you are tremendously successful. And
Hold on. Assume?
I didn't say you're not. I just said let's assume.
Okay.
And let's assume everyone signs up with you.
Okay.
So how do you avoid what you described earlier as like the Waze problem of you are generating the problem, and meanwhile you're clearing up all these paths that were broken before you moved to traffic?
That's a great question. Thanks for listening.
You're very welcome.
Here's the thing. We actually own also the IP for this solution. So I'm not going to describe everything, but the gist of it is if more and more traffic goes through Teridion, we can always improve it versus people who are not using Teridion. So maybe there will be time where Teridion will be the default thing for everybody to use. I mean, you'll deploy your server, you'll put Apache or Nginx or whatever, and you'll sign up for Teridion, and that's it. Because that will be the default thing to do. Because if you don't do it, you'll fall back to the regular internet. But even if Netflix and Hulu and HBO Go, and Snapchat, that are the biggest users of network these days, will use Teridion, we'll actually make sure that they will not congest themselves as a network. Because another unique thing for Teridion is we can create routes that the BGP cannot create. For example, the route from Singapore through Seattle, through Chicago so BGP cannot do this. Right now, Netflix can basically, use all the pipe between Singapore and if Netflix will be a customer of Teridion, or when Netflix will be a customer for Teridion, it will reroute them it will create so many routers, so many routes around the world. It will use sometimes routes that were never existed, from Singapore through India, through Amsterdam, New York, it never existed there. And we can create it. So we level the field for everything. So that's one thing. The second thing is CDNs and such have POPs and they have limited capacity. Now they can increase the capacity, but it requires contracts with adding pipes and peering and all that stuff. It's not something you can do ad hoc. For Teridion, we can scale unlimited. We don't have any limit on scale because we can start with one cloud provider and then move to another one, and then move to another one, move to another one. There are so many of them, and they have so much network, and we're just using that.
Do you have some mechanism to know like what the type of traffic is? Because going from Singapore through India to New York or whatever to have a VoIP call to here would be atrocious.
You'll be surprised. First of all, you'll be surprised. So the short answer is we don't know what type of traffic. Okay. We don't care.
Okay.
However, the customer, when he creates a VPN with us, he can say, I want this network. Remember that I started this by saying, what would the, hi to you too. The customer said, I want to have a VPN. I want to create my own backbone. And if I can make my own backbone, it will be like no latency and jitter, right? Because they're WebEx. He can't do it right now, right? When he signs up with us, he can say, I would like to make a network that is latency and jitter. That's the key things that I want to make sure that Teridion does for me. Now, when we make the route calculation, we don't know what it is. Maybe he's now uploading and downloading files. We don't know. But the route calculation looks at remember we measure things on the IP level? So this is an important thing. Because we measure things on IP level, we can say, actually, going through India, through Amsterdam, through New York, you'll be surprised. But we actually measured, this creates the less latency and jitter. Because we can take this knowledge, and when we calculate the routes, they calculate the route that has the least latency and jitter.
So when your customer like onboards and says, I want to create my VPN, and I want my VPN to prioritize latency and jitter over whatever else. Yeah. Is that basically how it works? He
can request it. If he doesn't request anything, we do it. But there's some intelligence about this. By now, after a few months, we can pretty much understand based on the behavior if you need to calculate latency or throughput. But that's a guess. If the customer tells us, by all means, you can get from day one much better performance.
Okay.
We usually encourage the customers right now. It's a high-touch sale, so we pretty much know where it is.
Right.
If it's Steve over here that's working with gaming companies, pretty much latency and not so much jitter, but latency. And for boxes and drop boxes, it's just sheer throughput.
Right.
So are you making effectively a per-customer decision for optimal routing per customer?
Yeah, so customers might have few networks. Okay, for example, a customer, any cloud storage provider, boxes, Dropboxes have their website that you can upload and download files. They also have their client, their sync client you can install on your PC, right? Most of them have this is one network and this is another network. Okay, so a customer can create a few VPNs, as many as he wants to, and by the way, each one of them can have different properties. Okay, so it's really, really, anything you can imagine, you can create your own network, whatever you decide to do with this.
So it's effectively it's constraint-based routing of a sort.
Of the what?
Constraint-based routing of a sort. You're defining, this customer says the most important thing to me is latency. Someone else says I need bandwidth is the most important thing.
And some customer might say, hey, can you please make sure that none of my traffic is routed through China? You've never thought of that, right?
Nope. Good thought.
Or you can actually say, here's something that I want you to make sure. Or a customer might say, hey, I'm worried about BGP hijacking. You familiar with BGP hijacking? Mm-hmm. It happened before. It will happen again. It's sort of like a black hole that sucks all the traffic through it for sniffing-ish reasons. If there's BGP hijacking where the customer tries to do Teridion, it's like two black holes competing. Eventually, it will break. So the traffic will not go to the malicious black hole. The worst thing can happen is it'll just break at some point. But none of the traffic will be affected. So it's a nice added feature that the customer gets when he uses Teridion. So we talked about the dynamic routing. Things can change, things can route. I explained about that. Mm-hmm. And so here's a little bit, this is the slide I was waiting for. So we have all those TMAs coming up, and they measure the internet, send the information back to the TMS. We deploy those routers all over the internet. Remember, no software, no hardware, no code change. Did I forget something? No problem. No problem. Good. And then the traffic goes through all these routers. And as we see that there's a better route, unlike BGP, we change it. And then if we see that, hey, over there on the top right, that might be even better, because the TMS has calculated that, then we deploy new TCRs, it's cloud, remember? And route the traffic through them. And delete this one. Oh yeah, avoid this region. We talked about some countries. China, sorry. And I think this is it.
So is everything encrypted in some kind of tunnel as it travels through your network? Or or as you're getting packets and they just...
We're a router. We're not touching it. It's like the regular routers, and they're really smart.
Right, so, but I guess the concern that some people would have is that they're really smart routers that are moving a whole lot of data, and that if I compromise that device, I can get access to a whole lot of data.
And what happened?
Well, let's
talk about the data is already secured. It's SSL.
Yeah, I guess.
It's already secured as end-to-end, right?
It's tunneled, right?
Between our routers?
Yeah.
It's our tunneling technology, but it's not encrypted.
Yeah.
But even if you break into the TCR, what are you going to do? See encrypted traffic? You can see the encrypted traffic right now. As a matter of fact, there was a known issue with AT&T that basically mirrored all the traffic and said, oh, everything that goes to AT&T was also sent to the NSA to be decrypted. I mean, if you want to, by all means, hack to the TCR, you're not going to. There's nothing there. It's a very smart idea, but the TCR itself, doesn't really carry data.
That'd probably inject latency too. If you tried encrypting everything, then you got to deal with that latency.
Oh, yeah.
So
And performance.
How do you onboard traffic? How do I get traffic from my machines to your service?
Great question.
Yes, please.
Oh, okay. I can't. He prepared for this. Why? The short story is that there are plenty of ways to do this. You can create a tunnel. You can add a route on your router. You add route, everything go here, or some stuff like that. Or you can do just a very simple DNS change. Bill will explain a little bit more about this, which is very similar to a CDN, the way the CDN works. It's little bit different because the CDN is just
like a reverse CDN.
Reverse CDN. And then if CDN is only when you download, but when you talk to the server, you go directly. For us, it actually has to go both ways, so it's a little bit more complicated. But then again, we have really talented people working in the Israeli office.
So DNS,
Not here, though.
tunnel.
No, you're here with just
or
pretty
BGP
people.
next
Just
up.
drink.
Yeah.
That's good.
The good-looking people are here.
Really just a CNAME change. All our customers just make a CNAME change to us.
Okay.
So Box is a customer. Instead of upload.box.com pointing back at their load balancer, they point at Teridion. We pick up the traffic and drop it off.
Guys, no one can hear you on this.
Can you pass them the...
So I'll repeat what Kevin has said, is that, for example, a customer might say upload.huli.com, we'll just not use a specific customer, upload.huli.com, and instead of pointing it to their load balancer, they're pointing it to a domain that we give them, upload.huli.teridion.net, and this gets to our router, and then from that point on, we know how to take it. And again, it doesn't require any SSL certificate or anything like that. It doesn't jeopardize our security. Actually, it has some benefits in security, and especially prevents people with masks to reach the traffic.